Lecture 14. Solutions. Objectives. Understand the process of dissolving. Learn why certain components dissolve in water. Learn qualitative terms associated with the concentration of a solution. Understand the concentration term mass percent and learn how to calculate it. Understand molarity. Learn to use molarity to calculate the number of moles of solute present. Learn to calculate the concentration of a solution made by diluting a stock solution. Understand this strategy for solving. State geometric problems for solution reaction. Learn how to do calculations involved in acid-base reactions. 1. The process of dissolving. Dissolving occurs when a solute becomes uniformly dispersed in a solvent, forming a solution. Steps in dissolving. Solute-solute interactions are broken. Solvent-solvent interactions are broken. Solute-solvent interactions are formed. A solution forms when the energy released in step 3 compensates for the energy required in steps 1 and 2. 2. Why certain substances dissolve in water. Water is a polar solvent. Like dissolves like. Polar and ionic substances dissolve in water. Nonpolar substances do not dissolve well. Key interactions. Ions dipole forces, ionic compounds in water. Hydrogen bonding, polar molecules. Example. NaCl dissolves because non-Cl interacts strongly with water molecules. Oil does not dissolve because it is nonpolar. 3. Qualitative concentration terms. These describe concentration without numbers. Term. Meaning. Dilute. Small amount of solute. Concentrated. Large amount of solute. Unsaturated. Can dissolve more solute. Saturated. Maximum solute dissolved. Supersaturated. More than maximum, unstable. Solubility of a solute in water versus temperature. Example solute, fictitious salt XNO3, values like many real solids. Units, grams of solute per 100 g of water.
Okay, here you have this curve that I made using this data. And as you can see, all the points that are over this line are saturated solutions. What does it mean? That they contain the exactly amount of solute at certain temperature. Look, if the temperature is lower, then less solute will be dissolved. If you decrease the temperature, less solute, and so on. The opposite, when you increase the temperature, larger amounts of solute are dissolved. But all these points that are over the line represent substances that have the exact amount of solute that can be dissolved at certain temperature. So we call this solution saturated. If you are here, for example, at this point, let me see. If you are here at this point, you can see that at 40 degrees, you can dissolve this amount of solute. But at this temperature, in this point, or at this point, you have less. So this solution admits more solute. And we call this type of solution non-saturated. The opposite, if you continue adding more and more solute to this at this point, very slowly, you will see that more solid can be dissolved. And if you go to this point, you can see that more solute that is then the possible one is dissolved. So at this point above the line, the solutions are considered supersaturated. Let's see which one is which one.
Unsaturated solution. Contains less solute than the maximum solubility. More solute can still dissolve. No solid present. Saturated solution. Contains the maximum amount of solute possible at that temperature. In dynamic equilibrium. Extra solute will not dissolve. Supersaturated solution. Contains more solute than should normally dissolve. Unstable. Small disturbance causes rapid crystallization. Key conceptual relationships. Property. Effect of increasing temperature, most solids. Solubility. Increases. Unsaturated, saturated. More solute can dissolve. Supersaturated. Easier to form at higher T, unstable when cooled. Typical exam question style. A solution contains 40 g of XNO3 and 100 g of water at 20 degrees Celsius. Based on the table, classify the solution. Answer: supersaturated. 4. Mass percent concentration. Definition.
Okay, let me stop into here. Now we are going to go to express of concentration. The mass percent is the mass of the solute divided by the mass of the solution. Remember this, that a solution is made of solute and solvent. Then solute plus solvent is what we call solution. Then if you divide the mass of the solute by the mass of the solution and you multiply by 100, you will get the mass percent, and it is an expression of the concentration of the solution. For example, a solution contains 10 grams of salt in 90 grams of water. You're not going to divide by 90 because 90 is only the water and the solution is solid plus solvent. So it is 100. 10 grams of salt in 100 grams of solution times 100 give you a 10%. That's a mass percent. In the case of molarity, molarity is the number of moles of solute dissolved in per liters of solution. Then the units are mole per liter. Example, if you have 2 moles in 1 liter, the solution is 2 molar. How can you get the number of moles? Well, if you have the molarity and you multiply by the volume, you get the number of moles. Example, how many moles are in 250 milliliters of 0.50 molars sodium chloride? Okay, the first thing that you have to do is to convert milliliters into liters. And then you multiply these liters by the molarity and you get moles of the solid. Well, dilution is when you have a concentrated solution. For example, you have 100 milliliter of solution that is 2 molar, and you want to produce, you have a certain amount of solution, 2 molar, and you need to produce a 1 molar solution, and you need to produce 100 milliliters. Then what you have to do? You have to calculate V1, the volume of the concentrated solution, to make the diluted one. Example, here you have an example that you can follow. What is the volume of 6 molar hydrochloric acid that is needed to prepare 500 milliliters of 1 molar hydrochloric acid? Then you go to the formula and then you need to take 0.083 liters of the concentrated solution to make a 0.5 liter of solution, diluted solution. Then, what is the strategy for solving solution stoichiometry problems? Look at this. Step by step strategy.
Write the balanced chemical equation. Convert volume moles using molarity. Use mole ratios from the equation. Convert moles desired unit. This is the same logic as reaction stoichiometry, but concentrations replace masses. Example, solution stoichiometry using the geometric, dimensional approach. Problem. What volume of 0.250 MnAOH is required to completely react with 35.0 milliliters of 0.200 MHCl? Step 1. Write the balanced chemical equation.
HCl, HAC más NaOH.
Hydrochloric acid plus sodium hydroxide produces sodium chloride and water.
The mole ratio between HCl and NaOH is 1:1. Step 2. Convert volume moles using molarity.
35.0 ml igual a
Okay, 35 milliliter is equal to 0.0350 liter. You divide milliliters into by 1,000 to convert milliliters into liters. And after that, having the moles divided by the volume will give you, sorry, if you have the molarity multiplied by the volume in liters, you cancel liter with liters, and the answer will be in mole. After that, from the balance equation, 1 mole of hydrochloric acid produces or reacts with 1 mole of sodium hydroxide. Then, if you have 0.07 mole of hydrochloric acid, that's also the required amount of sodium hydroxide to react with this amount of hydrochloric acid. After that, you convert moles into desired unit. For example, volume of sodium hydroxide. Then you say volume is equal to mass divided by molarity, and you get the volume. Volume in liter is converted into milliliters multiplying by 1,000. And then your answer is that 28 milliliter of 0.250 molar sodium hydroxide. That's the answer of this problem. Here you have another example of acid-base reaction, but we are going to stop into here, and we are going to see this in the next lecture.